Okay, let's go on with our Euclidean geometry, and we're going to have a look at question 3 now of my questions. In the diagram below, diameter EMA of a circle with center M. All right, so diameter EMA, circle with center M. So I know I've got radii, although I'm more interested in the diameter. Bisects angle FAB. FAB, there we go. So those two angles are now equal to each other. That's important. F sits on the edge of the circle. So if this is the diameter, then it must be subtending a 90-degree angle at the edge of the circle. That's our angle in semicircle. MD is perpendicular to chord AB. Okay, they've drawn this diagram in such a way that it can be quite tricky to see which theorem they're doing here. So I'm going to do some highlighting. MD is perpendicular to chord AB. All right, so the moment I do it like that, can you see it's like that T shape? And so we're talking about the theorem 1, which is a line from center perpendicular to a chord, also bisects the chord. They gave me the perpendicular, so I can say that it bisects the chord. So I now know that AD and DB are equal to each other. Right, then it goes on to say ED produced. Okay, remember that word produced is to talk about a straight line and sometimes an exterior angle. I think this one is more just to do with a straight line. Meets the circle at C. Chords CB and FE are drawn. So C and B lie on the edge of the circle. F and E lie on the edge of the circle. And if we're really looking at points lying on the edge of the circle, can you see that we've got A, C, B, and E all lying on the edge of the circle? And so I could have arc EB subtends A and subtends C. So that's angles in same segment. And then I can do it the other way around. Arc AC subtends E2 and subtends B. So I have angles in same segment again the other way. So remember, it's always an arc or a chord that subtends angles in the same segment. Arc EB, there they are. Arc AC, there are my angles. Okay, so now the first question hopefully won't be too challenging because we've filled in most of the relevant information. So let's have a look. Prove that triangle AEF, okay, so this big triangle over here is similar to triangle AMD, this one. All right, that's looking really promising because we already have A1 equal to A2. And we already have angle F equal to angle D1, although we've got to justify that. And so third angles of triangles will get us our similar triangles. Okay, so in triangle AEF and AMD, we already know A1 equals A2, given. Then we would have to state that angle F is 90 degrees because of angles in a semicircle, and therefore F is equal to D1 equals 90 degrees, and therefore E1 must be equal to M1, third angles of triangles. And so my two triangles are similar. So I'm going to play the TV chef again and just give you this solution. Okay, so in triangle AEF and AMD, we've got the 90 degrees. We've got the A1 equal to A2, which was given. And we've then got the E1 equals M1 third angles of triangles. Don't forget at the end to state the triangles being similar, and your reason is angle, angle, angle. Right. And remember, I said to you, get into the habit of filling in your third angles of triangles, because those two angles might lead you into something else in another question. All right, now for 3 marks, we must determine the numerical value of AF to AD. Okay, so AF to AD. All right, well, we've got AF compared to AD from our similar triangles. So let's see if that gets us anywhere useful. We can say that AF over AD, here it is, AF over AD, and now we can pick any of the other two. So we can say AE to AM. Let's have a look at that. AE to AM. Ah, that's looking promising. Alternatively, we could have had EF to MD. EF to MD. That's not looking as promising. So I'm going to stick with AE to AM. And the reason for that is obviously similar triangles. But now, AE is the diameter and AM is the radius. And so AE to AM has to be 2:1. Okay, and I'm just going to say diameter equals 2 times radius. And so I've already answered the question. AF to AD must be in the ratio 2:1. Okay, so I know that now, that AF to AD is 2:1. So if this is 2x, AD will be x. And if AD is x, then DB is also going to be x, although I will still have to explain that. All right, last question for 6 marks. Prove that AD squared is equal to CD times DE. Okay, so now there's a little trick over here. If they say AD squared, your first option is, do I have 2 different triangles that have AD as a side? Okay, and if I look over here, here's AD. I definitely don't have 2 triangles with AD as a side. Okay, in fact, I suppose I do, but they don't look the same. I could have triangle ADM, which is a right angle triangle, and I could have triangle ADE, which is very definitely not a right angle triangle. So I can't prove those 2 triangles similar to each other. Next best option, if I can't have 2 triangles, both with AD as a side, being similar, is what about if I have 2 similar triangles where one of them has AD as a side and the other triangle has a side equal to AD. So if I look more carefully now, I've got triangle ADE, which has AD as a side, and then I've got triangle BDC, where BD is a side, and we've gone out of our way to tell ourselves that AD is equal to BD. So it seems very likely that we can prove triangle ADE similar to triangle CDB, and then we can get the AD squared from there. All right, so let's have a look at those 2 triangles and see if we can get them similar. So I've got in triangle ADE, and triangle CBD. Remember, order is not vital now. It's only vital at the end. So we've already said A2 is equal to C. So we're going to write that down now. So angle A2 is equal to angle C because they are angles in same segment. Okay, and then I suppose next easiest is to use the other two. So E2 is equal to B, also angles in same segment. And therefore, angle ADE is indeed equal to CDB. And you can say vert-op angles, or you can say third angles of triangles. Whatever we state, we can now state that triangle A to D to E is similar to C to D to B. And that will be angle, angle, angle. All right, now I'm looking for this AD squared, but remember there's no AD squared, but I want AD, which happens to match with CD, and then I want BD, which happens to match with DE. So if I get my proportionality right, it's going to be AD over CD is the same as DE over BD. Cross multiply AD times BD is the same as CD times DE. Yay, I'm happy because look at that. And then I can say, but BD is equal to AD, and that's because of our perpendicular from center to chord. And finally, I can replace BD with AD, so therefore AD squared is equal to CD times DE. All right, it's a very nice 6-mark question. The important thing was to recognize where the AD squared came from and to exercise our options there. Right, next up. Question 4 looks like a nice proportionality theorem question. So let's see how complicated they might have made this one for us. So in the diagram below, triangle ABC is constructed such that BC produced to D, DR is drawn, then we've got point T on AC, R is on BA, and then they've given us actual measurements. So I've got a 12 millimeters, a 36 millimeters, a 20 millimeters, and an 80. So if SR is 20 and SA is 80, I would be perfectly correct in stating that AR is 60. And the first question, they want me to prove that CS is parallel to TR. Now, you might have already looked at that and just assumed that they were parallel. That would be wrong. You have to prove it. If I can prove that 36 to 12 is the same as 60 is to 20, then I will be able to prove that they parallel using the proportionality theorem. So that's where I'm going to start. So I'm going to say that AT over TC is in fact 36 over 12, which happens to simplify to 3:1. Notice I am not allowed to say AT over TC equals AR over RS. I will get 0 for the question if I jump straight in there. I've got to prove that they're equal. Okay, and then separately I'm going to go AR to RS is 60:20, which unsurprisingly is 3:1. And now, because they are the same, therefore, AT over TC is the same as AR over RS. And because of that, that's what we've proved. Therefore, CS is parallel to TR. Line divides sides of triangle proportionally. Okay, there is no other correct way to prove parallel lines using the proportionality theorem other than going really slowly. All right, it is further given that, so let's fill in those parallel lines, by the way. And I'm going to take that parallel line all the way across. It's further given that AR is 2/3 of RB. All right, so already that's not the nicest, friendliest way of giving information. So I'm going to take RB and I'm going to divide it on the left. So AR over RB equals 2/3. Do you see how that's much easier to understand? So AR to RB is 2:3. So that is now 2x. And that is now 3x, which gives us a total of 5x. BC is 2x. Oh dear. If BC is 2x, then I may not use x's here. This is a perfect opportunity to illustrate that. I'm going to make that 2y and 3y. Okay, and then CD is a half x plus 1. A half x plus 1. And they want us to solve for x. Okay, so these parallel lines take us into a new triangle. So according to this new triangle, BC over CD is equal to BS over SR. Okay, now I know that SR is 20. I don't yet know what BS is, but I do know that 2y is equal to 60. And so that's on my sketch. That is part of my working out. So I'm going to say 2y is equal to 60. And therefore y must be equal to 30. So if y is 30, then BR has to be 3 times 30, so it must be 90 millimeters, which finally means that BS must be 70 millimeters because SR is 20. Okay, so there were no reasons required there. I just had to work carefully. So I've got a 20, I've got a 70, which obviously means that the whole side would now be 150. Okay, right, I don't need that because I'm going to now say BC to CD, BC over CD must be 70 over 20, which would obviously be 7 over 2. So 2x divided by a half x plus 1, is the same as 7 is to 2. And now I'm going to neatly cross multiply, which is a shortcut for common denominator. 4x is equal to 7 over 2x plus 7. Okay, I don't love those numbers, so I'm going to go 8x is equal to 7x plus 34. Sorry, 14. How did I do that? I multiplied everything by 2. If I just wrote times 2 in brackets, I don't know where 34 came from, is equal to 14. Okay, so now 8x minus 7x is x is equal to 14 millimeters. Okay, let me just fix that. All right, so I don't like working with fractions, so double, double, and double. Okay, and there we are, 6 marks. Not much reasoning, but it's because I'd filled all the information in on my diagram, so I didn't have to show too much in the way of extra reasoning there. Right, let's see what's next. This video. In the diagram below, triangle ABC is drawn with PQ parallel to BC. Okay, so they're going to play around with parallel lines here. And RS parallel to AC. Okay, so we might be in a position where we've got to turn our sketch around a bit here. AQ to QC is 3:5. And BR to RA is 1:3. So I'm going to make that a Y. And that's going to be a 3Y. So that means this whole side is 4Y. And it means that this whole side is 8x, should I need any of that. Okay, and somehow I have to prove that AP is the same length as PR. AP is the same length as PR. All right, so the first thing I can do is I can say that AQ to QC is the same as AP to PB. So let's try that. So AQ over QC is the same as AP over PB, and that is because of line parallel to one side of the triangle, or proportionality theorem, and that is the ratio 3:5. Okay, so I now know that AP to PB is 3:5. Okay. Then I can also say that 4y is giving me the equivalent of 8x. Okay, so y in terms of x, I suppose, because I'm saying AQ over the whole of AC is the same as AP over the whole of AB, and therefore this little piece at the bottom, RB over here, which is a single y, could be written differently in terms of x. Okay, so I'm going to write it as AP over the whole side for y is the same as AQ over the whole side AC, which would therefore be 3x over 8x. Okay, let's have a look and see where that gets me. So the x's obviously will cancel out, and I'm going to get 8 times AP is equal to 12y, which means that AP is 12y over 8, which is 3 over 2y. Okay, so now AP is 3 over 2y. The whole of AR is 3y. So therefore, PR must be 3y minus 3 over 2y, which is fantastic because 3 minus 3 over 2 is 3 over 2y. So what have I done? I've proved that AP is 3 over 2y, PR is 3 over 2y, and therefore I can conclude that AP is indeed equal to PR. Okay, it feels like a complex question for 7 marks, but it's just to keep your head and to make sure that you don't, in fact, overcomplicate this particular question.